Hi, welcome to our session on maturing applications of augmented reality. My name is Jeff Siegel. I'm a Vice President and Technology Services Director for HNTB. Along with me presenting is Adam Horn with HNTB as well, who is the team lead of our Civil Integrated Solutions team at HNTB. The session today is actually packed full of content. We have some high-end learning objectives here. First is to look at the understanding of maturing applications that we're using in the industry of architecture, engineering, and construction. We're going to define some maturing use cases, as well as look at specific use cases in 3 different categories. 1, in the field, 2, using remote assistance, and 3rd, using tabletop and web enabled augmented reality. So I'm going to set the stage here. This is all in the realm of a pattern we call in our industry virtual design and construction. Something we're using more and more on our largest capital programs and projects to improve business performance on our projects, to accelerate time, save on schedule, definitely improve on quality of deliverables, and really lead to true 3-dimensional model data that's used by multidisciplinary teams on our projects, from electrical engineering to roadway engineering to rail to HVAC, all kinds of disciplines, all working together on these large programs with many different stakeholders. And what we're able to do is augment this 3-dimensional smart modeling with different realities. We're talking about 3 different types of realities, of course. 1 being virtual reality, using things that typically you would see as animations or just true visualizations of a project. Augmented reality, when we're starting to mesh that virtual models with the real world. And then, of course, merged reality or mixed reality, often called as well, where we can actually take that augmented reality and interact with it and manipulate it right in the physical environment we're working in. And really the whole tone of this presentation is about where we're at on the adoption curve for augmented reality. You can see many of the technology patterns we're seeing in our industry and how us and our clients, meaning the owners, public owners, are adopting it. And augmented reality is really taken off into true production, almost to the level of virtual reality. And you're going to see some of those maturing applications all throughout this presentation. Why is that? Well, we see a lot of barriers initially, working in this realm of mobile wearable technologies and augmented reality just a few years ago. We're already seeing these barriers fade away. Devices are seeing much better battery life. We're seeing much better network bandwidth out there, many more mobile computing device choices, and prices for the software and the hardware are dropping. So we're seeing much more ability to both functionally as well as sort of the business side be able to adopt these applications more effectively. And now we can see the realm of opportunities because of those fading barriers, whether it's from collaboration, so connect remotely from individuals that are communicating and view and interact on the same data in the field, augment data to the technical folks all the way to the way they work, so they can be more in the office and work with people in the field and immerse themselves in the same environment. Learning, workforce development is a huge one that you'll see some examples later in the presentation of where you can immerse training and workforce development workflows right into the AR environment. And then finally, explore, how can we enhance the engagement experience for all stakeholders on a project, not just the technical folks working in the field, but even to the public that are viewing these projects that are going on. So we're going to look at a whole bunch of case studies very quickly, but we've organized them into really three areas. One, field AR or field augmented reality. And that's really in the realm of the case studies there of collaborate and know. Second, case study around remote assistance, where learning is the priority and working with workforces to develop their skill sets. And third, tabletop and web AR, how we can enhance for all kinds of stakeholders, from public to the non-technical folks and even technical folks, to really understand what's going on in a complex environment. So with that, I'm going to turn it over to Adam to really dive into some of these case studies.
Thanks, Jeff. It's a really great introduction, and I'm excited to be here with you as well. So, starting with field augmented reality, this is really for HNTB. This was really our core use case in the infrastructure market. The ability to take our complex designs out into the field and interact with them and visualize them. What we found very early on, however, is that augmented reality in the field can be very challenging, especially early on. Things like accurate location of our models in the field, network latency that Jeff mentioned, inherent drift with devices was a real problem. So early on, we identified some of those challenges, and then we're working with software and hardware that could overcome some of those for our field use cases. One of the first projects where we deployed field AR was a project in Florida for a right-of-way use case where the goal was to be able to engage landowners in a new novel way to show them where a proposed roadway design would affect their property. So we investigated the best softwares for that minimized our kind of challenges with location and drift, because the goal was to show discrete lines to people, so it needed to be accurate and not drifting. So we found a software called VGIS that actually had kind of a novel approach to location in the field using a 2-point calibration technique rather than relying on the location services of the device. In this video, you'll see an example of how that 2-point calibration technique is used. So you're able to locate yourself on a map, and then you orient yourself with a 2nd-point calibration. And at that point, the data streams in and is locked in place. There's also some fine adjustment that could be done here, also horizontally and vertically, to fine adjust your data to the correct location. As part of this project, we also deployed a HoloLens Generation 1 HoloLens, and you have the ability to do the same 2-point calibration. The HoloLens was important for us because we wanted to provide a more natural viewing experience for landowners and the public to view this information. What we did find were some challenges with this as well. We quickly realized that the HoloLens sun glare is a major problem with the HoloLens when viewing data in the field. We actually added window tint to the front of our HoloLens, which really helped with that experience. We were able to see things better once we tinted the windows, if you will. And And we also found that the 2-point calibration, while really effective on a flat device, became a bit of a challenge for people unfamiliar with how to use a HoloLens. But what you'll see in this video is kind of an example of the same 2-point calibration and viewing experience that was recorded with the HoloLens. So you've got a map where you can locate yourself, and then you perform the air tap to orient yourself with the second click, which was the biggest challenge with this because it's augmented reality. Only the person wearing the HoloLens knows what they're seeing. So it became a bit of a challenge for us to help with the 2-point calibration with a user that wasn't familiar with the air tap. But here you'll see the data streaming in now and locking into place. So existing trail here, the red line being the new proposed right-of-way line, the major line of interest here. And as we're walking up, you can see minimal drift happening. We're also getting additional data is available upon using the gaze technique with the HoloLens. When you gaze on a line, you will get additional information that is stored with that as metadata. So since the FDOT project, we have seen a lot of advancements around field AR as that technology has matured. There have been a lot of enhancements made and expanded functionality. Things like virtual markup, issue tracking, the ability to collect information in the field, the ability to create data in the field, as well as added geometry. So early on, we were really limited to lines and points, and we've started to progress now to the ability to stream larger, more complex models. An example of that expanded functionality is the ability to create information in the field as well. As you'll see in these videos, an example of that data collection. On the left, you'll see a flat device in the field where the data is being streamed in. A user is in the field and is creating a fire hydrant. The video on the right is the same, it's the same location at the same time with a HoloLens. The person on the left creates the fire hydrant. That is then immediately available for viewing through the person using the HoloLens. So you can see the person here collecting the fire hydrant. That fire hydrant has just been created and it's instantly available for viewing in the HoloLens. One of the latest advancements is the ability to use reality capture and then view that in augmented reality. So here we can see that we have collected this open trench while the new utility was being placed. And now you can see that's what it would look like after the construction is complete. And so now you have the ability to go in and actually see in an augmented reality view what was installed and how it was installed when the trench was open. So you can physically walk over that pipe now and see exactly what's underground. We're also seeing the ability to see more complex geometries, as I said. So now we're seeing more features in here and additional geometry types. You know, we're getting tubes, structures, more 3D models in here. And finally, truly complex building designs in 3D in the field, which is sort of the latest advancement. This functionality has been in place for a while in the interior space, but taking it out into the field is one of the more recent advancements that we're leveraging right now. The next use case that we've seen a lot of advancements and adoption in is remote assistance. This is really important for a lot of reasons. Maintenance management, staff turnover, knowledge transfer, and also support for maintenance activities in the field. For example, MDOT is experiencing a large workforce turnover within their maintenance department. And they're forward thinking about how are we going to manage that knowledge transfer to support new hires and keeping our level of maintenance service running with the reduced staff and newer staff. So remote assistance in the field has a lot of applications. The first one really being just providing more information to the maintenance staff while in the field, whether it be documentation or just utility information. For example, here we're able to see exactly what's underground and how it was installed, and if there are any other conflicts related to this utility. Also collaboration, which has been brought even more prevalent given the current pandemic, but the ability to collaborate from the field to the office for decision support and also just design collaboration. So the final use case that we want to talk about today is web and tabletop augmented reality. It's really providing that advanced collaboration environment through design teams, remote design teams. You'll see in this video the ability to take a standard 2D plan drawing and scan that with a device and see the actual 3D model of it on your desk. It's taking that 2D design file and making it an interactive 3D experience so that you can get a much better understanding of how this will be built. Also, fully immersive environments for design collaboration, team collaboration, and an augmented view. And finally, as Jeff had mentioned, it's how can we then take that experience beyond just our internal design teams and make that experience available even to the public? One of the use cases that we applied this technology to was for public involvement and public outreach around new projects. So we developed an experience that really could be within your living room. So you could actually provide an augmented digital assistant who could provide you information about an upcoming project. He could ask for your feedback and could provide an interactive experience around your favorability for an upcoming project. So in this video, you'll see an example of what that could look like. So scanning a QR code, and then you will have a digital assistant in your living room to tell you about this upcoming project.
Hi there. I'm your digital augmented reality engagement assistant for the next couple minutes. At any time during our conversation, you can use your smartphone to snap the QR code on top of the coffee table and launch a feedback form. We'd love to hear your thoughts on today's experience. Traditional hearings and handwritten comment forms no longer satisfy the technological expectations of the public. Along with our state agency partners, HNTB is at the forefront of modernizing public engagement. Imagine the screen in front of you highlighting a project you care about. while I walk you through the project details. Next, imagine the tabletop scene we've created here today is placed in your living room. This virtual experience allows you to engage in project development at a time and place that's most comfortable for you. HNTB has developed the Public Involvement Management Application, or PIMA, to encourage public input in a modern and efficient way. To give it a try, simply scan the QR code on the table below and experience the value PIMA brings to the public process and the decision makers who use it. I hope you enjoyed your experience with me today, and I look forward to helping you make your next project a success. Thank you from all of us at HNTB.
Great. So with that end of the virtual assistant, I'll take over and just say it's been really cool to share all these use cases with you. And we're constantly looking and thinking about additional ones as our work continues to get more and more virtual. And with that, we are open to questions.